So, very good morning, students. So, welcome to IIT NEET Foundation Program or Focus C by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the class 7 students so far for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 7, our ongoing chapter, electric current and its effects. And today we are entering into the session number 2. So far we completed one session on the basic concepts of electricity, starting from the history of electricity to what is electric charge, what are conductors, what are insulators, what are semiconductors, then what is electrification, how to give the charge for a neutral body. In that there are so many, are the electrification by friction, electrification by conduction, electrification by induction. Right. So these things we learn in the first class along with some video also. Now we'll continue where we'll stop in the last class. But before that, you can see here. So there are two kinds of charges are identified long back by great Greek philosopher Thales, as they are identified as positive and negative charges. Whenever the charges flow, the flow of charge is called electric current. What is flow of charge? It may be either positive charge or it may be either negative charge. Flow of electrons or flow of protons, they're known as electric current. So based on the flow of current, all the materials, all the substances are classified into conductors, insulators, and semiconductors. Conductors are those which allows the current to pass through them. All the metals, including gold and silver. There are some more substances like rubber, wood, plastic. They does not allow the current to pass through them. They are called insulators. This third category is there, which allows the current partly or partially or not completely. Some part of it allows. They are called semiconductors, like silicon, germanium. Right. Then when you are giving charge, generally I told atom is electrically neutral. No doubt. Atom is electrically neutral because it contains same number of positive charges, same number of negative charges. But by adding electrons or by removing electron, we can make the body charge the body. That process of giving charge is called electrification. So it can be done by either by rubbing, called friction, or connecting the uncharged body, charged body, that is called conduction, or by keeping the bodies even away also, without direct touch also, we can give charge for a body. That is called induction. Like that, even lightning, which we taken place in the nature, is also process of giving charge. Whenever two clouds or cloud and dust particles, cloud and earth, they collide, they give the lightning for us, followed by a sound called thunder. This is a nature phenomena of discharge of electricity. Right. Then we discussed about what are the main sources. Right. What are the sources of electricity? So electricity comes from so many sources. So there are small source of electricity are there. Small source means which can give some amount of current. Like we have cell, right? Cell is there. Battery is there. They are small source. There are large source also there. Large source of electricity. Large source like, for example, generator. Right? Transformer. You can see transformers outside. Then also inverter. Depends on our requirement, we can use them. So they are, but these all comes under the small source and large source of electricity. Right? So for example, if you take a generator can give some amount of current. For example, so much amount of current it can give. The amount of energy given by generator is called electromotive force, EMF. For example, when you see at home, current will come from the electricity department, from transformer to meter. So household consumption required 220 volts. We require 220 volts of current, right? Or potential difference, you can call it as 220 volt. So the 220 volt is supplied by the meter. That is called EMF. If you see a cell EMF is only 1.5 volt. If you see any cell which you are using for remote control or using for the car toys and all, the cell capacity is 1.5 volt. We've written on that. What is that 1.5 volt? The energy the cell can give, which is called electromotive force. If you take big battery, torchlight battery, you take battery will have 3 volts. There are some 6 volts batteries also available. We can use in laboratory. 9 volts batteries. So what is all this is nothing but electromotive force of that particular device. Generator can give more amount of how much you required, depends on your requirement. If you go to industries, they require 720 volts of current. That is supplied by department from the transformers. So this all comes under electromotive force. The energy that source can supply, right, is EMF. Short form is EMF, electromotive force. Then when you move forward, some more terminology is there we'll discuss. So there are so many types of cells are there. So there are dry cells are there, like we are using in the, I told, remote controls and torch lights, radios, right? Cells and batteries. They are called dry cells. Dry. Because they contain the dry chemical. So what happened? The battery converts the chemical energy into electrical energy. But there are some liquid cells also there. Suppose if you see in your two-wheeler or four-wheeler car or lorry, bus or DJ, when you arrange the functions, they'll give the big batteries. Inverters will have big batteries. They are liquid batteries. They contain the liquid chemicals. Right? So like voltaic cell. As per our requirement, you can use. Voltaic cell is one kind of cell. Similarly, we have the bichromatic cell. So every cell is having their own advantage as well as disadvantage. But as per our requirement, you can use any of these cells. The explanation part is not so much important. Leclanche's cell, dry cell. Dry cell is the one which you are using in the torchlights or remote controls, right? So it contains completely a dry chemical. So the dry chemical energy is converting into electrical and makes us to use the for play toys, toy cars or remotes or anything. That is dry cells. In that also there are two types of cells are there. One is primary cell, other one is secondary cell. So primary cell cannot be recharged. We can use only for some days. 1 month, 2 months, after that we have to throw that. But there are some rechargeable cells are there, which can be recharged again. You might have seen, we'll use the rechargeable batteries with charger. Whenever charging is completed, you can keep them and you can keep the charge like mobile phone. So they are called rechargeable batteries. Even in mobile also, we have the rechargeable batteries only. They are secondary cells, they are called. Primary cells are those which cannot be used again and again. They're not replenishable. But secondary cells can be recharged. Like that, there are two types of dry cells again. So, right, this is about all are about the sources, main source of electricity. Then, when you come to the word of electric circuit, right, elements of circuit. What is circuit? Suppose you go to home. After going home, what will do? Switch on the light or switch on the fan. When switch on at one place, we are getting the light at other place. How this light and switch are connected? They are connected by one cable, which we cannot see. Maybe internally connection is there. So one is switch, very important one. One is bulb, that is called source. Source means meter. And third one is consumer. Let me explain you. Consumer. And last one is wire. For every electric circuit, these four are important. So switch is for on off. For on off or for braking we'll use. Source means there should be some source. For example, there is no meter. There is no electrical supply to your house. Will the bulb glow? No. because some source is required. It may be generator, or it may be inverter, or it may be power source. So switch, source, consumer. Consumer means which utilizes the current, like bulb, iron box, TV, cooler. All these are the concerned consumers. When these are connected through a wire, when all these are connected through a wire, and such arrangement is called simple electric circuit. You can make it in school also, simple way. You might have done in so many science experiments also. When the two wires are joined, bulb will glow. So you'll take one battery, bulb, and two wires are joined. And you can keep switch also, on and off switch. So these four together makes one simple electric circuit. Like that in our house, we have so many circuits are there. So because we not having one switch, we have hundreds of switches and number of fans, number of tube lights, number of other electrical devices. All these are connected through wire only. There is a wire which you cannot see, which is concealed inside. So whenever a source of electricity, which is like a meter or inverter or generator or battery, and a consumer of electricity like fan, tube light, which utilizes the current, and a switch, which make or breaks the circuit, connected through wire, then such arrangement is called simple electric circuit. Right? Simple electric circuit. So that is very, very important definition. The circuit can be either closed circuit or open circuit. Closed circuit means switch on. When switch is on, the circuit is called closed. When the circuit is closed, current will pass. So open circuit means switch off. No current passes. For example, see here. I'll simplify an example. I'll say. So say this is the symbol of battery. That is source. I represent like this. Suppose say this is the bulb. Bulb is the consumer. And say this is the switch. And these three are connected like this. Whenever current passes, right? So this switch is up means it is open circuit. Is open. But when you close the switch like this, it is a closed circuit. Current passes. But open circuit means bulb won't glow because switch is off. When switch is off, current won't glow. When switch is on, current will glow. So off position is called open circuit. On position is called closed circuit. When you close the circuit, current flows and all the appliances will glow. So this is representation of circuit. Simple. One source of electricity, one consumer, one key, and wire. These four are minimum requirement to form the simple electric circuit. Right? Very, very important. Then come to the synopsis 2 for today's. We have the synopsis here, which explains about the very important electric current and its effects. We'll see. I'll explain you a few terminology regarding the electric current and also what are the effects of electricity. So when you come to electric current, first we'll see what is electric current. So electric current, the flow of electric charge. So mathematically, I is equal to Q by T. Mathematical formula for electric current. I is equal to Q by T. So Q, what is Q here? Q is charge. Charge by time. Charge by time. Rate of flow of charge, you can say. So electric current is nothing but the flow of electric charge carried by moving electron. Right. So what is the unit? Ampere, name of the scientist. Generally, charge is measured in coulomb. The unit of electric charge is coulomb. Time is second. That is, you can write coulomb by second, or simply standard unit is ampere. Right? Very, very important concept. So whenever there is a flow of current, depends on the how fast it is flowing. That is called rate of flow of current. Sorry, rate of flow of charge. Rate of flow of charge constitutes the electric current. So mathematically, I is equal to Q by T. Right? Where Q is called charge, T is called time. So Q is measured in coulomb. Again, name of the scientist. And time is measured in second. The coulomb per second is also known as ampere in SI unit, SI system, right? International system. So this is about the electric current. So what are the effects? We'll discuss later. whenever you pass electricity through various substances, what effect we can see? That is comes under effects. So, but before that, some more definitions. Conductor, already you have seen, a substance that flow of passage of current. Metals like copper, aluminium, silver are the good conductors, or gold. If you see any wire, any wire where the current is passing, out upper part of the wire is covered with the insulator, because when you touch, should not feel shock. But inside we have the all conductors only, copper, right, or aluminium, not silver or gold, because they're very costly. We cannot buy the cable with gold, right? Then insulators, opposite, a substance that does not allow the passage of light, right? Very important. Then this will come across electromagnet. Whenever you pass the current, magnetism is produced. That we'll see later. So electric circuit, we just now you have seen an important element of electric system, where there is a flow of current through a cable. Then magnetic field, you know, what is the effect of magnet around it? Heat is also one of the important effect of electricity. When you pass, for example, iron box, you take, switch on the light, iron box. After some time, touch it, it become hot. That means electrical energy is converting into heat energy. Then very important one is electric fuse. You know fuse? Everywhere you have the fuse. Even two-wheelers, four-wheelers also you have fuse. At home also you have fuse. So fuse is a device made with the melt and breaks when the light current passes through them. When the large current. Whenever high voltage comes, sometimes what happens? Fuse will burn. If fuse is not there, what happens? The fuse is of low melting point. Low melting point. I think you know what is melting point. Where it is, material is melted. So generally we use the fuse with the low melting point, because whenever high voltage comes, whenever the high voltage current comes, what happens? The fuse will burn and stop supply to the house. If that is not there, what happens? All appliances will burn. Fridge will blast, tube light will go, everything will go when there is no fuse. That's why we have used the fuse to protect our appliances, right? Protect our appliances, we use the fuse. Correct or not? Okay. So the fuse is used to protect our appliances. So very, very important device in electricity. So these are the few terms you'll come across when you are, similarly you'll come across even EMF, I told already, electromotive force. The energy is supplied by a source. So we have so many sources of electricity. So many sources are there, like cell, battery, Leclanche cell, bichromatic cell, dry cells, all, and generators, inverters, transformers. So many are there. All these will have capacity of supplying electricity. That energy is called electromotive force, which is measured in units called volt. Again, scientist name is Volta. It is named as volt. So these all terms come across when there is a term electric current comes, right? So we are discussing about what is electric charge, how many types of charges are there, what are conductors, insulators, semiconductors, then electrification, electrification by friction, electrification by induction, electrification by conduction. And now we have seen so many types of batteries. In that again, primary cells are there, secondary cells are there. So primary cells are like which can be recharged, non-rechargeable cells, whereas secondary cells can be rechargeable. Okay. So there are two types of cells are there, rechargeable and non-rechargeable. So rechargeable cells you can again get back. Okay. So that is total information, basic concept of electric current. Now when you go for the effects, what are the effects? What happens when electric current passes through solids? What happens when electric current passes through liquid chemicals? What is the effect of electricity? That I have seen already, I told. Whenever current passes, bulb will glow. Bulb will glow, that is called lighting effects. When you touch the bulb, it produces heat also, that is heating effect. Correct? Similarly, crane, electric crane with air, that produces the magnetic effects. So there are so many effects are the electricity. So before going for the explanation, I'll show you one video on the effects of electricity. Then we'll move to the explanation part. Okay. Right? Just keep watching the video before going for the explanation. So what are the effects of electric current? When electric current passes through any conductor, what happens?
Electric circuit. The closed conducting path in which the electric current flows is called an electric circuit. An electric circuit constitutes of a source of electric current, cells, etc., a conducting wire, an electrical appliance, bulbs, etc., a switch or key. When the switch is closed, the circuit is said to be closed circuit. In this condition, current flows and appliance works. Example, the bulb glows. However, the circuit is said to be open circuit when switch is open and there is no flow of current.
See, open circuit.
Source of electric current. A device that produces an electric current is called a source of electric current. Example, cells, batteries, etc. Battery. When two or more cells are used to draw an electric current, the combination of cells is called battery. In battery, positive terminal of one cell is connected to the negative terminal of the next cell. Many devices such as torches, transistors, toys, TV remote controls use batteries. Bulb. It produces light and is represented by coiled wire inside the circle as shown. Connecting wire. The connecting wire is represented by a straight line. It is usually made of copper and provided with insulation. Plug key. A plug key is an electric switch. It is shown in both on and off positions in figure. Cell. A thin long line represent the plus terminal and thick short line the negative terminal as shown.
Draw the symbols.
Battery. A combination of two or more cells is called battery. Its symbol is also a combination of cells symbol as shown. Fuse. It is safety device in electric circuits. The components such as cells, bulbs, wires, etc. are called elements of an electrical circuit. The various components of the circuit are represented by standard circuit symbols. It is much easier to draw a circuit diagram using symbols. Therefore, we generally represent an electric circuit by its circuit diagram as shown. Symbols of some common components are shown. Heating effect of current. When an electric bulb glows continuously for a long time, it becomes very hot as some part of the electrical energy is converted into heat energy. This is known as heating effect of current. The heating element in many electrical appliances like electric rod, electric oven, electric toaster, etc. is made of nichrome alloy.
Nickel and chromium.
Take a 10 centimeter long piece of nichrome wire. Tie it between the nails. Now touch the wire and switch on the current in the circuit by moving the switch to on position. Touch the wire again. Do not hold the wire for a long time and switch off the current. Touch the wire again. After a few minutes, we will observe that the wire becomes hot when an electric current passes through it. This is the heating effect of the electric current. Safety devices. Mini circuit breaker used to protect circuit from strong current. Strong current often leads to overheating of wires, which can result in the breakout of fire. Fuse also used for protection of circuit, which consists of a thin wire of low melting point. In 1820, the Danish physicist Hans Christian Ørsted discovered that flowing current in a conductor generates a magnetic field. Ørsted demonstrated this by connecting the two ends of wire to a cell through a switch. Then he placed magnetic compass near the wire. Now when he allowed the current to pass through the wire by closing the switch, he observed deflection in magnetic needle. He also noticed that it requires its original position when the flow of current is stopped. Take a discarded matchbox and wind an electric wire a few times around the cardboard. Place a small compass needle inside it and connect the free ends of the wire to an electric cell through a switch. Note the direction of the compass needle. Bring a bar magnet near the compass needle. We will observe that the needle gets deflected. At the same time, move the switch to the on position. We will again observe that the needle gets deflected again. Now move the switch back to the off position. We will observe that the needle comes back to its original position. So, we conclude that when electric current passes through a wire, it behaves like a magnet.
Very important.
Take the tray from inside a discarded matchbox. Wrap an electric wire a few times around the tray.
The simple equivalent you can do. Only you need battery.
Place a small compass needle inside it. Now, connect one free end of the wire to the terminal of a battery. Leave the other end free. Take another piece of wire and connect it to the other terminal of the battery. Insert free end of wires into half cut of potato and observe. You will observe that a compass needle gets deflected and also find that it was always the wire connected to the positive terminal which has greenish blue spot around it. They felt that the discovery was very useful because it could be used for identifying the positive terminal of a cell or a battery concealed in a box. Electromagnets. Current-carrying wire or a coil of wire behaves like a magnet. If a permanent magnet is brought near the coil, one end of the coil gets attracted and the other end gets repelled. This shows the opposite polarity of the coil. If a piece of soft iron is kept inside this current-carrying coil, the iron piece gets magnetized temporarily. Such magnets are called electromagnets.
Electric bell. An
Bell also
electric
effect of
bell is one of
electromagnetic.
the most commonly used applications of electromagnets. It works on the magnetic effect of current. It produces a repetitive buzzing or ringing sound when an electric current is passed through it. Electric bells have been widely used in telephones, fire and burglar alarms, at railroad crossings, as doorbells, school bells, and alarms in industrial plants, but they're now being replaced with electronic sounders. An electronic bell consists of an electromagnet, springy iron strip, a hammer, a gong, and a switch. An electric bell works on the principle of electromagnetism. It is a simple device which has a U-shaped solenoid, one end of which is connected to a spring of the switch, and the other end is connected to a soft iron armature.
Observe, it is a
Basically,
structure of the
all the
electric bell.
components such as the switch, electromagnet, hammer, soft iron armature, and spring are connected in a circuit to make an electric bell. When electric current is allowed to pass through the circuit, the iron core of the solenoid gets magnetized and pulls the soft iron
Yes,
armature,
here, current passing.
which causes the iron hammer to strike the gong. When the armature moves toward the poles of the solenoid, the circuit breaks and the solenoid
Hammer
loses
hitting
its
the bell.
magnetism. This forces the armature and the hammer to return back to their original position.
Right. So this is the video about the complete what is electric current and its effects. So when you come to the part of effects here, effects of electricity, I already told there are 4 to 5 effects are there. Number 1 is heating effects. Before explanation, let me give the heating effects. Means when you pass electricity, it produces heat. The second one is lighting effect. Right? Lighting effect means when you pass electricity, it is converted into light also. Third one is magnetic effects. Right? Magnetic effects means whenever current passes through a conductor, it produces magnetic field. Then very important one is chemical effect. So whenever electric current passes through a liquid chemical, it produces electrolysis process. Very important process. You might have learned in your lower classes. Electrolysis. Whenever current passes through salt water, so it is decomposed into ions. Na plus Cl minus. That effect is called chemical effects. This is also useful in the many purposes in our day-to-day life. And last one is, one more very important effect is electromagnetic induction. Electromagnetic. This will come across in higher classes effect. Right. So like that, whenever electric current passes through different conductors, it may be solid conductors or liquid conductors, it will use the various effects like heating effects, lighting, all effects are helpful for our day-to-day application. Heating effects, lighting effects, magnetic effects, chemical effects, and finally electromagnetic induction. Electromagnetic induction also one of the effect where we can see the electrical and magnetic fields combined will give different type of results. Right? Clear? So next class, and today and tomorrow also we have class, we'll continue to discuss about the effects in details. And this total syllabus will cover for your upcoming test 5, which is on 25th, that is coming Monday. Monday, you have the test 5, where you can, right? Right? So these are the various effects of electric current. Just a minute. Heating effects, lighting effects, magnetic effects, everything. For example, if you see, just now we have seen video also. So when you see heating effects here, right? When you see for heating effects, you can come across bulb, iron box, geyser, right? Heater, room heater. So what all these will do? They produce the heat when you are passing the current. When you are passing the current, they are producing the heat. Lighting effects, of course, bulbs. You can see bulb, tube light. What they are doing? When you are even refrigerator also you can find the light. AC also you can find the light, digitals. So what they are doing? When you are passing electric current, they are converted into light also. That is called lighting effects of electricity. Light. Even electric fuse also one of the heating effects. That fuse heat will produce us from the damage. So you can see on the screen, so many effects are there. So in next class, we'll discuss in deep about these effects, right? Heating effect now. Now you can see when you turn back, we can have the various type of magnetic effects is there. Similarly, electric effect, chemical effect also will be there. Okay. So we'll see all how they work and how the electricity affects the conductors, right? So that's all for today. You can see on the screen your home task. Define electric current, mention its units, the first question. Second one is mention various effects of electricity, only mentioning. Heating effects, lighting effects, chemical effects, magnetic effects, right? Right. So note all these questions and okay. So that's all for today. Thank you all of you. Have a wonderful day. So write down and write in your notebooks. Designate some teachers and your parents. 2 questions. So tomorrow class we'll discuss details about the effects of electric current. All the effects. So thank you all of you. Have a wonderful day. Thank you.